What's going on, guys? Let's look at this problem right here. Here this question is asking if the collector current Q1 is equal to 0.5 milliampere, calculate the value of Is. Okay, this is the one we are going to do right now. Okay, now let's go ahead and draw the Thevenin equivalent circuit for the given circuit. The Thevenin equivalent circuit will be the 2.5 voltage remains the same, and here the 50 ohm resistor right here, kilo ohm resistor, and then this is Thevenin equivalent, okay, bottom we have 30 ohm resistor, 30 kilo ohm resistor. Now first we are going to calculate the Vthevenin. Vthevenin can be calculated using this resistor. Like if you want to find out the voltage across this 30 kilo ohm resistor, you have to do the voltage division. Voltage division is basically you take the voltage source, that is 2.5 voltage, and multiply by whatever the one you are trying to find. If it's 30 kilo ohm, that's going to be on top. 30 kilo ohm, if you want to find out the voltage across this 30 kilo ohm plus over the addition of these two resistors, that is 30 kilo ohm plus 50 kilo ohm, and that gives us 937.5 millivoltage. Okay, now we have found out the Thevenin voltage. Now the next thing is we are going to calculate the R Thevenin. R Thevenin is equal to multiplication over addition, product over sum. 30 kilo ohm multiplied by 50 kilo ohm divided by 30 kilo ohm plus 50 kilo ohm, and that gives us 18.75 kilo ohm. Now the base current is provided. Here we have collector current is provided, that is 0.5 milliampere. Collector current is 0.5 milliampere, and if the collector current is this, then base current is IB is basically equal to IC over beta. Here beta is equal to 100, so 0.5 milliampere divided by 100, and that's our base current, that is 5 microampere. And there's another equation for IB, that is Vthevenin minus VBE divided by R Thevenin. From this one we can solve for VBE because we know Vthevenin, that's right here, and we know R Thevenin, we found out right here, and IB is here, so we can find out the VBE. If we rearrange this one in terms of VBE, that's going to be VBE is equal to Vthevenin minus IB times R Thevenin, and let's plug all the values. Vthevenin is equal to 937.5 millivoltage, 37.5 millivoltage minus IB is 5 microampere multiplied by R Thevenin, that is 18.75 kilo ohm, and that gives us 843.75 millivolt. Now the next thing is we are going to solve for IS. VBE is equal to VT ln of IC over IS. Let's go ahead and plug the values. VBE we found out that is 843.75 millivoltage, that's equal to 26 millivoltage, ln of IC, the collector current is 0.5 milliampere divided by IS. Now here if we solve for IS, that's going to give us 4.03 times 10 to the power of minus 18 ampere. That's the question is asking for. The question is asking for the value of IS. We just found it out. Okay, now the next thing is we are going to do the B part. Let's get rid of all these things. Okay, Let's look at the B part. The B part is asking, if Q1 is biased at the edge of saturation, calculate the value of IS. Okay. Q1 is on the edge of saturation. So if it's biased at the edge of saturation, means VBE is equal to VCE. Okay, and here we can find out the VCE using this formula. VCE is equal to 2.5 voltage, 2.5 voltage minus, because that is VCC minus IC times RC. IC and RC is 3 kilo ohm, 3 kilo ohm. And here IC, instead of IC we can plug this one. IC is equal to beta IB. And instead of IB we can plug this equation, beta V Thevenin minus VBE divided by R Thevenin. R Thevenin. And if we plug this one in this equation, instead of this IC we plug this one, this equation, let's say this one. In the one equation we are going to plug IC, this term instead of IC. So the equation will become VCE is equal to 2.5 voltage minus, instead of IC we put this one, beta V Thevenin minus VBE divided by R Thevenin multiplied by 3 kilo ohm. Now let's go ahead and plug all the values. 2.5 voltage minus, instead of beta we plug 100, and instead of V Thevenin we plug 987.5 millivoltage minus VBE divided by 18.75 kilo ohm. These are the values we calculated previously, so I directly put it right here. And yeah, if you calculate this one, you are going to get VCE to be VBE to be, because VBE and VCE are same because of the edge of saturation. So if you solve for VBE, you are going to get 830 millivoltage. Okay, now that's it for VBE. Now the question here is asking us to find out the IS. IS is IC divided by exponential of VBE divided by VT. Instead of IC we can plug beta, this equation, beta minus, actually beta times V Thevenin minus VBE divided by R Thevenin, and the whole thing divided by exponential VBE over VT. Now let's go ahead and plug over the values. Beta is 100 and V Thevenin is 937.5 millivoltage minus VBE is equal to 830 millivoltage divided by R Thevenin, that is 18.75 kilo ohm, and divided by exponential VBE is equal to 830 millivoltage divided by 26 millivoltage. So from this one we can solve for IS. IS gives us 7.84 times 10 to the power of minus 18 ampere, and that's our IS value, and that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.